Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we will solve another question from Leetcode. So let's get started. Yep. So today we have partition labels. So yeah, on these questions, what actually the problem statement they have given to us. So we will go step by step. We will first understand the problem statement, then we will build our algo, then we will go to the code iterations, and post that we will do the time complexity and space complexity analysis. So that's the agenda we are generally following. We will follow the same for today. So let's get started. Yep. So you are given a string S. We want to partition the string into as many parts as possible so that each letter in at most one part. So they have given a string S and we want to partition the string. So we want to break the strings into as many parts as possible, so that each letter, what is the letters appears in at most one part. So if you break a string which is given to you to a particular partition, so and if you are stating that your letter A is a part of partition 0 and partition 1. No, that is not the case. So if you are breaking a string to a two partitions or n partitions, then each partition should have a characters which is only identical for that partition. So that letter is not going to repeat to any other partition, as simple as that. Now they have given us an example. So that is the string they have given to us, A B C C, and we can partition it in two different segments. So here you can see one is AB and another one is CC. But partitions such as ABA, BCC or AB CC are invalid. Why so? Why first one is invalid? Because B is occurred as a part of two partition. B is a part of partition first one and the second one. And on this you can see the violations. A has occurred to partition 0 and 1. B has occurred to partition 0 and 1. So that is also an invalid split. And now note the partition is done so that after concatenating all the parts in order, the resultant string should be S. So it is as simple as that. We are not going to partition the strings like in a way so that like after merging. So let's suppose we do a partition at index 0 and index 5 and index 7. So how many substrings we are going to build? We build so 3 partition. Number of substrings should be 3 plus 1, 4. So we have four chunks of subarray. So what they are stating, so after merging them all in the order you have done the partition, they should be again back to S. They have to again back to S, right? So it is quite simple, like quite explanatory itself. And now after that we have to return a list of integers representing the size of these parts. I think question is very straightforward and there is no super magic we have to understand here. And yeah, now let's try to understand the first test case. So here you can see, and there is one more things we have to do as many parts as possible. So there is a greedy thing. So they are basically stating, so by these keywords they are basically asked for when you have the feasibility to do a partition from a particular index, then do that. So they basically asking for what is the maximum partition, what is the maximum partitions we can build. So that's the reasons they have asked for as many parts as you can divide your resultant string, the given string what they have given to us. So on this you can see we have first partition done as index 8 from 0 to 8. So we have this one. So what is the size? The size is 9 for this partition. Then we again do a partition from index starting from D to E. We have a chunks of length 7. So this chunks is length 7, and we have another last one which is another chunks which is length of 8, and we have to return. The first partition length is 9, the second partition length is 7, and the third partition length is 8. As simple as that. So here you can see they have write some English. So this is the partition so that each letter appears in at most one part. Yes. So on first partitions we have letters only A, B, C only. Second partitions we have D, E, F, G. On third partitions we have I, H, J, K, L. This guys. But here you can see, like if a particular letter belongs to first partitions, this should not be part of any other partition. It is applicable for all the characters. If you can choose any arbitrary characters, this particular character frequency only you can find on the partitions, on the targeted partitions, not on the other partitions. Yeah, on second test case you can see like you are not able to make any partitions altogether. So your what is the given string to you should be your like only altogether your answer. So here we are returning 10. So that is the given string length. Is as simple as that. And the resultant string of size can be of 500 and is consists of only lowercase English letter. I think the question is very simple. I have to say it is not altogether like a medium, but yeah, like for implementation perspective or a little bit, but I have to rate it like easy medium kind of question only. Yeah. So now Now let me just tell me guys. So what is actually the invalidity? What is actually the validity? So if you are stating that if I am stating at that particular index, if I am standing at, let's suppose, at index C, so can I make a partition here? Can I make a partition here? Okay, so then I will ask you, so hey Shouvik, if you want to make a partition at index having element C, which I am marked highlighted, if you want to make a partition, na, then very start from where you have done the last partition, from very start where you have done the last partition. So as you are going to only very start partition only, so our very first partition should be at index 0 or maybe at before of the index 0 only. So if I am asking you, can I make a partition here? So what is the validity of yes or no? What is the validity conditions of, I can say, yes or no? So the validity conditions should be all the letters where the partition started from, where the partition started from has their last occurrence is less than equals to my C, should be less than equals to my index C, right? And what about, like, if I choose this particular segment, can I make a partition here? What is the check of validity? So I have make a partition at index C, and post that I have started a new altogether subarray, and if I want to make a partition at index I, inclusive of index I, then all the letters of this particular chunk or this particular subarray has their last occurrence is less than equals to my I, correct? Exactly. If you are not following, like, let's go to our very favorite OneNote and try to understand what I am basically trying to state. So what we have. So let's suppose. Can I write? Yes, I can write. I have fixed my pen, I guess. It's a little bit lagging somewhere, but yeah, we can manage. So let's suppose we have these things. Let's suppose we have a chunks of characters only. Let's suppose that is of x, y, z, then again x, y. Then let's suppose that is, let's make it last occurrence, then z, then let's suppose we have a something like this. So if I am ask you, we are very greedy. We whenever there is a feasibility, na, we will try to make a partition. So the very start feasible index is this. Can I make a partition at x? So can I make a partition at x? So hey, if I am making a partition, so x should be, all the occurrence of x should be whatever the partitions I am considering ending at x should be part of x. X should not be part of another partition. Oh, okay. So if this x is the last occurrence of character x, if that is so, then I can make. Correct? But if it is true, no, we have a x exist at this index, so it is false. So we can make a partition at this particular index. So we can't. So let's go forward. We have y. Okay, we have y at that particular index. Now can I make a partition here? So then on that case, all the characters, now on last case we have only single characters in our partition. Now all the characters starting from, I know what is the starting point from this particular partition to this index should have their last occurrence within the boundary which I am highlighting repeatedly. If that is the last occurrence of x, no, x is further. So easily, just on blind eye I can say that is not possible because x has further occurrence. Can I make a partition at z? Again same case, no, x has further occurrence. Okay, now I am at this particular index. Can I make a partition at this particular index? So for x, yes, x it is valid. For y, is that is the last index where y occurred? Nope. Y has furthermore. Y's last occurrence is furthermore. So we can't make partition here. We can't. Okay. Let's go forward. So if I am at this index, can I make a partition here? For x, yes, you are on good state. For y, okay, you are also in good state. For y also you are in good state. But you have a character z that is a part of the partitions you are trying to make. but for him I am getting a value that z, for z it is the not the last index where z has occurred. So you can't do a partition, here. So because of z, it is also invalid. This particular index also invalid. Okay, now we move forward. We are at this particular index. Can I make a partition here? Yes, x last occurrence is here, y's last occurrence is here, and z's last occurrence also at this particular index. So starting from whichever index you are following, you can make a partition. You can make a partition here. You can make a partition here. Right. So when we are making a partition, if I can extend our test case a little bit more, let's suppose we have b here and we have a here, and get some more place, and we let's suppose have p here. Now when you are making a partition, now that is a point of validity. So do the partition, because we are ready, we will do the partition. And when we are doing our partition, we know that this particular index we are starting a fresh things from this particular index, right? And we will do our same things. So for a is, can I make a partition here? No, that is not the last occurrence of a has occurred here also, you can't. So for b, can I make a partition here? For b, though you man are fine, but you are considering a partition which I am highlighting, considering a and b. For b, though you are fine, that is the last occurrence of b. But for a, man, it is not valid. For a, it is not valid. So you can't because a has further more occurrences. So which you are considering the index, a has occurred somewhere later. So let's go forward, man. So can I make a partition here? Tell me, can I make a partition here? For b, though I saw you are on good state. For a also, now I am going to get that for a also it is the last occurrence. So yes, that is also a valid point of partition. So let's do a partition here. And you will reset whatever the starting you are following. You are starting from p. So like this way, I think you guys got the gist how actually we have to iterate, and this is one of the valid segment. So on the answer things, we have to push. On first case, we a 1 2 3 4 5 6, we are able to get a length of 6, and for second one we are able to get a length of 3, I think. A only, yes, ABA. And for the last one only p is there, so that is the answer you have to return, the length of the each partition in the order you have done. So I think you guys got the gist. So what actually basically allowing you to make a partition to a particular index, is nothing but these things, is what is that particular index where you are basically lying on. That particular index is the last occurrence of the very start, where you have done the very last partition from after that partition, which of the characters you are considering. If all the characters occurrence is the index where you are doing the partition, is all of them should be less than or equals to where you are trying to make a partition, If that is so, then do the partition and reset your start and whatever you are following, and do the same things repeatedly. So what actually the things which is basically making the validity, is valid, which is basically making the validity. So that is basically the last occurrence of all the characters you are considering in the particular partition, the last occurrence of all the characters you are considering. So if all the characters are good, they are basically stating, yes, my last occurrence within the boundary. When you are trying to make the partitions thing, man, you do the partitions, you have the ability to do the partitions. The algo is as simple as that. So basically, now let's go to the code iterations. I will explain the things to the code itself. So I have two submissions, I guess, mostly. So I will first basically want to explain the first solutions, which is basically taking a little more time, that is of 16 milliseconds, and the second solutions is basically top of a slight tweak of the first modifications, and we are able to basically land on the most optimal time complexity. So let me just first explain the first algorithms, because that is basically create your base, how basically we are. So why I am explaining the first solution, because the first solutions is basically, second solution is basically the top of a few slight modifications on the first solutions, but on the first solutions your logic building or your understanding skills is going to be built on the first solution itself, and the second solution is just like topping settings to your cake to make it more crisp and clear and run it in the most faster way. So yeah, so what I am on the first solutions I am following, I am creating a default dict. So as we are following from last few videos, so default dict because we need these things. So why we need? Because we want what is the last occurrence of a particular character, what is the last occurrence of a particular characters to our resultant string, to the given string. So we are iterating from I equals to 1, I from in range n, and we are storing d of s of I equals to I, d of s of I. So the if s of I is the character, I am storing the index, So let's suppose a has occurred multiple times, a has occurred at index 0, 1 and 5. So every times when we are going to get a occurrence, I am going to update the index it has encountered. So like this way, this particular frequency map is storing all the characters is in our given string s. What is the last occurrence? What is the last index they have occurred? What is the last index they have occurred? I think it's very simple. And now I have started with my answer, and I am going to booleans with last present as a false and last to a -1. I will explain where it is going to be help us. I will explain this. And we are also following a running dict. So I am basically the mental model. I am following the running dict as a this particular segments which are following. So basically I am stating now, if I am able to make a partition, I will reset whatever the data structure or whatever the things I am following. Because I have done a partition, because after that I have to start a very fresh. I have to make a fresh start. So my running dict is going to be refreshed every time when we are able to make a partition. It's as simple as that. Right? So now we are going to our for I in range n, and what we are doing, we are taking a possible as true, because possible is basically stating us, can we make a partition, and we are basically storing this particular character. There is I add a +1 to it. You can add anything, but I need the entry to our running dict, because that is the characters we have encountered, which is inside the partition, which is inside the substring we are considering. So right, so that's the reasons you can add 1 also, +1 also, anything, but I need an entry, I need a key for this particular character to our running dict, because this particular running dict is storing what all the characters of the current substrings we are following. And now I am iterating to each elements of our running dict, because we want to, right? Because what on the examples we are stating, if you are at a particular index, let's suppose this, you whatever the running dict basically storing all the characters of this particular substrings, all the characters like x, y, z, everyone is storing, and we want to check if all the characters in our running dict should be under our boundary. So how we will check? We will call our actual dictionary, because on actual dictionary we are storing the last frequency where they have encountered. So yes, we are doing the same things. So we are iterating to our running dict, and we are checking if d of each. Now you can see, like, we are making a call to our actual dictionary. If that particular index, so running dict holding the all the characters for that particular substring, we just make it as a highlighted on one node, and we are iterating to our running dict, and we are checking all the characters like d of each. If it is greater than my I, because I am currently standing at index I, if its occurrence, if it is last occurrence, so d of each is basically stating if for the particular each character which I am considering is its last occurrence is more than my I, then on that particular point I am making out possible. So possible basically stating if at index I can I make a partition. So I am making my possible as false, because that particular index is occurred some later part I can't make a partition, and I am breaking. And if after iterations of our running dict, if it is a possible partitions, then I am checking what is the last present. If last present basically stating if we are all together considering if we our run, are we able to make a partition at any point earlier? Right? So if it is not, because initially we have false, so that is the first partitions we are able to make to our resultant string. If it is the first partitions we are able to make, then what? Then we are appending our answer to the size of this partition. What is the size of the partition? If that is the very fast partitions altogether, what is the size? I index is 0 based, so I +1, and we are making our last presence is true, because we are able to make a partition. And we are storing what is the last index where we made the partition. So we are able to make a partitions at index I. We stored it. And if it is a already partitions, so something like this, where it is, so when you are making a partition here, this particular index, so you have already made a partitions here, and you are making a partition here. So what is the size then? What is the size then? Can I say it is just like I minus last where we made the last partitions? It is I am currently at I index, and I made the partition at this last index here, and right now I am at this index. So can I call it, if our last presents, like we made a partitions at last times, like we are already done a partition. So for this particular valid segments, can I make, so that is the particular segments where we are able to make our first partitions. Yes, we can. Yes, we can. Yes. So on that case we are storing I minus last. That's just I explained, as simple as that. Sorry, here also like I minus last, and finally we are returning our answer. So one quick optimizations if you guys are able to make on this particular question. So first tell me guys, what is the time complexity for this particular solutions? We are doing a for I in range n, that is taking a big of n. So that we anyhow have to do. Let's not consider this. So inside that you can see that we are running n loop for sure, and under n loop we are running a for loop on running dict. So what is the maximum key we have on our running dict? That is of 26, because on English we have 26 characters. So the maximum length of our running dict can be 26. So these solutions is kind of 26 into n. What is the time complexity? 26 into n for this particular solutions we just discussed. So now it may be the interview. So mostly the interview should be good if you are able to explain these particular things, and if you like give your entire thought process and give the particular gist of why it is of 26, and mostly like interviewer satisfied. But if you are on the very top notch product based company, they might be ask you to reduce the 26 factor. I don't want the 26 factor at all in the time complexity. Can you make a big of it? This particular things, can you make a big of it? Then you have to think a little bit more. So why we need a running dict? So we need a running dict because we want to check the partitions which I am considering. If all the characters, the partitions I am considering, all are under my boundary, under my ith index, where I am trying to make a partition, if all are under my boundary, so I think I can make it a little bit more intelligent way. I don't need a running dict altogether, because I already have my dictionary ready, and when I am considering a particular characters, I will check. I rather than carrying a dictionary altogether, which is also taking a space also, I can carry a max variables. Which is basically stating what is the maximum all the characters I am considering till now. What is all the characters I am considering till now? Out of them, which of them has the very last frequency? Which of them is the very last frequency? If I can carry this informations to a variables altogether, if I can carry this all informations to a single variables altogether, so can I say our job is done? Do we need this running dicts altogether? Because if our max, which is basically stating, so what max is stating? Why I am repeating? What is the significance of max? Max is basically giving you the informations from the substrings you are following. Inside that, whatever all the characters if you have had, out of them, what is the last occurrence? Very last occurrence out of them. What is the very last occurrence of the characters? So if you have A, B, C, and let's suppose A's occurrence is last occurrence at index 2, B's last occurrence at index 1, and C's last occurrence, let's suppose, at index 7. So your max is going to be hold informations of 7. So when you are, let's suppose, trying to make a partition at 4 index, your max is already going to give you the informations. No. So there is a character named as C. I don't also want to get the informations. What is the characters? Maybe the characters can be anything, A, B, C, whatever it is. But there is a character for sure whose last occurrence is more than the current index you are stating. You are landing. So you can't make a partition. You can't make a partitions to this particular index, right? Yes. We can carry something max variables. So exactly that's what we have done to our solution 2. Now also maybe I can put the two solutions left and right all together, so you can see like what extra tweaks I have done. So till this point everything is same, and I have removed this running dict altogether. I just removed this running dict altogether. Did I remove anything else? No, I didn't remove anything else. Till this particular point, both are identical. That too we have to do. And now we are initialize our mx. So that is our, what is the last occurrence of all the characters we are considering to this particular substring. We have initialized to 0, and we are maximize it. What is the max value we have? And d of s of i. S of I is the character, and d of s of i is the characters which I am considering, and d of s of I is the last occurrence of that particular character, and I am maximizing this. What is the max value? It's currently my max has to the to the characters, to the frequency digits, current characters last occurrence, current character last occurrence. So we have the max ready, and if we have the max ready, so do we need to do this extra jobs running to our running dict? No, we can do a straightforward check. If my mx is less than equals to my I, so all the characters last occurrence is under my boundary I, under my boundary index I. So then if my last present, so these things exactly same. If last presents, then append to I minus last, and if not, then append to answer of I. We will append to I plus 1, and we will making our last present as true, and finally we are storing at last I. So these things, like if possible, na, so this entire job we have to basically need to make our possible variables to be set to our possible variables. And we can do to set our possible variables. Now that is the possible functions if mx less than I. So if we are able to make our possible variable set by making a check mx less than I, the entire things under possible is as it is, right? And now we remove the for loop. Altogether, and yes, I think that is the most optimized time complexity and space complexity I am able to find. So what is the time complexity? Let's quickly iterate to you guys. So we are doing a standard big O of n things here, and here also we are doing standard big O of n. Not more than that. Yes, agree guys. So we can write it as big O of 2n. And what is the space complexity? The space complexity is we anyhow have to create a frequency list. Not frequency list, what is the last occurrence of the characters, and what is the maximum size it can grow. So we have only 26 alphabets, so it can grow at as big as 26 only. And after that, do you feel guys we are using anything? Answer, I am not considering, because I am personally feeling that if we have to return a list, then you have to consider a list. So that is ideally not going to be a part of your what can I say, like on space. But if your interview want to consider, then you can consider. So in that case, your answer size can be of big O of n altogether, and your n can be what bigs, like 26 only. But yeah, like let's not consider answer. But if you want to consider, then you can consider. But your answer size can big as 26 only. It's clear, right? I think it's very straightforward and intuitive, because you are maybe at very worst case you are able to make at every partitions at every index A, B, C, D, E, F, Z, H, like to Z, and after that all the characters should be a part of a single partition. So on that case, that is going to be a length of a single partition only. So that's the reason it is going to be a 26 only. I think it's very intuitive only. And apart from that, we are obviously carrying a default dict, and every character is going to be pushed on a default dict only once, and that is a big O of 26. So it is as simple as you can consider, and it's as equivalent to a big O of 1, because it is a constant factor. 26 is a constant. But please explicitly mention it is a big O of 26. That is going to add up more advantage to the other candidates. So that's basically pinpoint. You are able to clarify your time complexity and space complexity in exact number point, exact mathematical form. So please write it in something like big O of 2n. So I know it is a big O of n, but write it as big O of 2n. So that means you are following every variables, every iterations you are following throughout the questions. So that basically a top of a cherry to your interview. So please mention in terms of like mathematical forms. So yes guys, that's it for today's question. And if you are able to understand till this point, so I know what you guys have to do. Please do subscribe to our channel. Please share the videos to your friends and to your connections who are basically preparing and brush up their DSS skills. Please share the videos to your connections, and please turn on the notifications so that when we are going to live with our next video, you will get the notification as soon as possible. So that's it guys. That's it for today. Bye guys. Bye.